Okay, let us discuss the next problem. So you draw the diagram and then we will discuss what the problem is saying. So you just draw the diagram. So this is just same kind of question from the last one. You make the diagram and then we'll discuss. Make a pause on your computer if you don't have so much time. Okay, let us discuss now this problem. Now, in the last problem there was a resistor at this point. Now we have a capacitor. So this resistor is basically replaced by a capacitor. Now this time I don't say you to find velocity. This time I say find out the acceleration of this connector, not the terminal velocity. In the last question we have found a steady state velocity, that is the terminal velocity. But in this question I am saying find out, I am not saying, this is Rudolph is saying, find out the acceleration of the connector. So acceleration, what is the acceleration of connector? Now everything is same. I have a connector of length L, mass of connector is m, this rail is smooth, no friction, this B is perpendicular to the plane of loop, and there is a capacitance C, angle between connector and horizontal is alpha. These all things are given. Now once again, if you derive the direction of current, it should be up, because then only there will be a force that is up. So current, direction of current should be this side. You see, once again, if the current direction is this side and magnetic field is perpendicular, so I delta L cross B will be up. So direction of current should be such that in this way. So that only causes a force that is up. That will basically reduce the motion. So now you see, I can make a projection from this side. If I look from this side, it will look something like this. Now what are the forces? One force is mg sin alpha, that is the component of mg. Mg cos alpha I am not interested, because that will be balanced by normal. So I am getting a new unknown normal. So what is the point of writing that force? There is no point of writing that force. Now what will be this force? This force will be I delta L cross B, but this time I don't know the I. Once again, this force will be I L B, but I don't know I. Now let us say how to find I. Now if you see this rod is moving, this is the only part that is the difference from the last problem. In the last problem I was having I is simply BL by R, but in this case slightly modification. You see what modification we can do. Across the connector, what is the potential difference? I can find BLV is the potential difference across the connector. Now what is the charge on capacitor? Q is equals to C times potential difference across capacitor. Potential difference across capacitor is BLV. So charge across capacitor is BLB into C. Now I can differentiate this Q. So dQ by dt is equals to I. BCL is a constant, but velocity is changing. So we will have BLB, BLC, dB by dt. Now, so upward force I will have I delta L cross B. I have already said. So that is ILB, that is the force. So we will have force is I is, now we have calculated from here, that is BCL dB by dt. So BCL dB by dt is I into L into B. So this is the upward force. Now let us plot this upward force. I am going slightly fast. You just copy this one and then I will discuss. I agree, I am going slightly fast. When I write and then try to speak, in that case I think we go slightly fast, and that is also not so interactive. If I write and then keep speaking, that is more interactive. What do you think? Try to analyze this one. Okay, so let us go to the next. So the force downward is mg sin alpha, force up is b square L square C dB by dt. Now the total, now this block is coming with acceleration down dB by dt. So acceleration down is dB by dt, or A you can say. So dB by dt is acceleration. So now I can write total force downward, that is mg sin alpha minus b square C square L square C dB by dt is equals to m dB by dt. Now from here you calculate dB by dt, you will get this value, g sin alpha by b square L square C by m 1 plus. So you will get the same value. Are you getting or not? You try to do your own calculation. So see, what is the important point in this question? You see, you can remember this result. If we have an inclined plane, you have a resistor, then in that case you will get a terminal velocity. If we have a capacitor, in that case you will not get a terminal velocity. You will get a constant acceleration. Now you see, acceleration is constant. This acceleration is constant. This is not a function of time. B is constant, L is constant, C is constant, alpha is constant. So this acceleration is constant. Even you can change the acceleration also. If you keep changing the alpha, this dv by dt is again not constant. So you see, in the previous question, V was constant. In this case, dv by dt is constant. But let us say, even if I change alpha with omega t, now dv by dt does not remain constant because alpha is a function of t. Are you getting or not? So I can even change the acceleration, that is accelerated motion. So what can I do? If I have this situation and if I keep this changing, like this goes slightly up or slightly down, or it can rotate. So this means alpha is changing. In that case, that the acceleration will also change. We have a such kind of problem. If you remember, this kind of problem already asked in JEE. One problem in which you have a rod that is rotating also. So we will do that problem also sometime later. So these are two small problems, and we'll discuss some more problem from magnetic field and modern physics also. So let us finalize here.